In this demonstration, I will show you the different ways in which you can start a batch job in EKM. I will also show you how batch jobs work by submitting a sample job to an HPC cluster. There are a few different ways in which you can start a batch job in EKM. One way is to display the Applications panel. I can do this from any view by clicking the Applications icon in the header bar. The Applications panel contains all of the job templates and applications that I am permitted to access. By default, two built-in job launch applications are available here, Start Batch Job and Start Interactive Job. Start Batch Job is a generic application that enables me to start a batch job by defining standard job submission settings, such as the queue, application, and command line arguments. Another way to start a batch job is through a job template. Job templates contain predefined job submission settings and can include additional custom settings as well. By default, the Applications panel contains 4 built-in job templates. Each one is designed to work with a specific ANSYS application, CFX, Fluent, Mechanical APDL, or Electronics Desktop. When you start a job using one of these templates, solver-specific settings appear in the Execute Batch Job dialog box, the same types of settings that you would define if you were running the solver on your own machine. Any custom job templates that have been created and shared with me will appear on this panel as well. You can also start a batch job directly from a file that exists in the EKM repository. Simply right-click the file and select More Execute Batch Job. As with any batch job, you will be prompted to specify job submission settings and will also be able to upload more files to the working directory if needed. To demonstrate how batch jobs work in EKM, I am going to use a custom job template to submit a Fluent batch job to the queuing system of an attached HPC cluster. To start the batch job, I'm going to display the Applications panel, and then click on the Custom Job template. After accepting the default job name, which will be used for monitoring purposes, I am asked to upload input files to the working directory on the compute cluster. Input data can be selected from the local file system, the server-side file system, or EKM's data repository. I'm going to upload files from both my local machine and the repository to form a set of input data. For the first input file, I'm going to select the Local System tab. Conveniently, I can drag and drop a file from my desktop or a file explorer directly into the staging area of the Upload dialog box. Next, I'm going to upload an input file from EKM's repository. So I'll select the Repository tab. Here I'll click Add to have a look at the repository file system. I'll select an input file, then click OK. I am satisfied with my input selections, so I'll click OK to proceed to the next step. With the input files now uploaded to the working directory on the compute cluster, I can specify my job submission settings. Because I launched the job from a job template, the fields in this dialog box are already populated with the settings defined in the template, saving valuable time. Note that this template is just one example. You can easily create any number of custom job templates to suit your specific needs. Whether I use a template or not, I am free to specify or override any of the values shown. In this case, I can choose the queue, the number of cores, a journal file, the solver dimensions, and its precision. When I click OK, the job is added to the queuing system, and the job is displayed on the Job Monitor page. Initially, the job has a queued status. When compute resources become available, the job will begin to execute, and the status will change to executing. The job status will update at regular intervals, but I can refresh it at any time by clicking Refresh. In the interest of time, I'm going to skip ahead to the point where the job has been executed. At any time during a run, I can select the Transcript tab to view detailed information about what has occurred. In this case, the transcript confirms that the job was executed successfully. Next, I'll select the Working Directory tab to access the results. The toolbar here enables me to interact directly with the working directory on the compute server. For example, I can transfer files to my local file system or to the EKM repository. If I choose to download files to the repository, EKM automatically extracts metadata as well as a simulation details report from the files. An interactive 3D image may also be extracted if EKM is configured to do so. All of this information is displayed in a standardized format in the object view without any manual post-processing required. The Simulation Details report contains a static image of the simulation model, as well as information about model settings and boundary conditions. Initially, the report is part of the simulation file, but I can copy the report to make it a separate object in the repository file system. I can also download the report to my local machine as an Excel, PDF, or XML file. This concludes the demonstration on submitting batch jobs in EKM.